Earth's surface reveals a consistent ratio. 29% is solid land, or lithosphere, while the remaining 71% is covered by the hydrosphere. This surface area is divided into the 7 continents and 5 major oceans that define our current geographical baseline. We navigate this distribution using a coordinate grid. The equator divides the northern and southern hemispheres. Vertically, the prime meridian and international dateline separate east and west. The northern hemisphere holds most landmass. For example, the Indian subcontinent sits entirely north and east. These coordinates provide a temporary geological snapshot of a much older dynamic system. Consider the shapes of the landmasses bordering the Atlantic Ocean, specifically the eastern coastline of South America and the western coastline of Africa. This map from 1596 shows early European cartography. Even with distorted proportions, the Dutch mapmaker Abraham Ortelius noticed a distinct symmetry. The coastlines mirror each other. Antonio Pellegrini later visualized this connection, drafting a map that physically joined the Americas, Europe, and Africa into a single block. The flawless fit of coastlines across a vast ocean suggests the continents occupied very different positions in the Earth's past. In 1912, Alfred Wegener formalized these observations into the continental drift theory. He proposed that all continents were once part of a single supercontinent, Pangaea, surrounded by the mega-ocean Panthalassa. Wegener argued that 200 million years ago, Pangaea fractured into 2 massive blocks, Laurasia in the north and Gondwanaland in the south. His case relied on geological forensics. Radiometric dating confirms that 2-billion-year-old rock formations on the Brazilian coast perfectly match the age and composition of rocks found in West Africa. Further evidence comes from tillite, an unsorted sedimentary rock formed by glacial deposits. Thick layers of tillite are found in tropical regions like India and Madagascar, meaning they once shared a unified southern climate. There are also placer deposits, concentrations of heavy gold. Abundant gold is found on the coast of Ghana, but the region lacks source veins. The matching gold-bearing rocks are located thousands of miles away in the Brazilian plateau. The biological record provides more data. Fossils of the Mesosaurus, a small freshwater reptile, are found only in South Africa and Brazil. These sites are now separated by 4,800 kilometers of saltwater ocean. Wegener's proposed mechanisms, the polar fleeing force and tidal force, could not sustain the weight of his evidence. Physicists demonstrated that these forces were millions of times too weak to shift solid continental masses. While his observations successfully mapped the history of continental movement, he died before science uncovered the actual mechanical engine of the Earth's interior. The mechanical answer emerged in the 1930s when Arthur Holmes proposed the existence of convection currents operating within the mantle. Radioactive decay within the Earth generates extreme heat, creating massive thermal convection currents that slowly churn the semi-fluid rock of the mantle. Scientists mapping the ocean floor after World War II discovered massive underwater mountain ranges called mid-oceanic ridges. Dating revealed crust at the center is brand new, while rocks age moving toward the coastlines. In 1961, Harry Hess synthesized this into sea floor spreading. Volcanic activity at ridges forces magma up, creating new crust. The ocean floor acts as a massive conveyor belt, expanding from the center and carrying the continents along with its lateral movement. This discovery led to the modern theory of plate tectonics. The lithosphere consists of several heavily fractured plates floating on the semi-fluid asthenosphere below. Fracture lines define these plates. The Pacific is primarily oceanic, while the Eurasian is continental. The globe has 7 major plates: Antarctica, North American, South American, Pacific, Indo-Australian, African, and Eurasian. Minor plates between them include Cocos, Nazca, Arabian, Philippine, and Caroline. The Indian subcontinent, originally part of Gondwanaland, drifted northward on the Indo-Australian plate until it collided with Eurasia, physically reshaping the geography of Asia. Plates interact in specific ways at their edges. Divergent boundaries occur where plates pull apart, creating new crust at sites like the Mid-Atlantic Ridge. Convergent boundaries are destructive zones. Here, plates collide, forcing the denser crust to subduct or dive beneath, the lighter plate, where it melts back into the mantle. When continental plates collide, the crust crumples upwards. The Indo-Australian plate driving into the Eurasian plate generated the folded rock layers of the Himalayas. Global maps of major earthquakes and volcanic activity align with these tectonic boundaries. The friction of plates grinding together is the direct cause of seismic events. Our continents and oceans are simply passengers on a highly active thermal engine. Review the high-yield facts. The Earth is 29% lithosphere and 71% hydrosphere, with 7 continents and 5 oceans. Wegener proposed continental drift in 1912. Pangaea was surrounded by Panthalassa. India originated in Gondwanaland. Arthur Holmes proposed mantle convection to explain the movement, which Harry Hess confirmed in 1961 with seafloor spreading. The lithosphere is broken into 7 major plates and minor plates like the Nazca and Arabian. Active subduction and friction along the margins of the Pacific Plate create a continuous loop of earthquakes and volcanoes known as the Ring of Fire. Study the exact locations of the major and minor plates. Know the mechanisms and the evidence. Stay sharp.